Hey! Welcome to NerdRevy. Today we will try to understand about rotational dynamics. Let's get started with our first topic. So what's rotational dynamics? Let's try to understand. Rotational dynamics is the study of the motion and behavior of objects that are rotating around a fixed axis. This field of physics deals with the forces and torques that cause rotational motion, as well as the energy and momentum associated with this type of motion. Rotational dynamics is important in many areas of science and engineering, including astronomy, mechanics, and material science. It helps us understand the behavior of spinning objects such as planets, gyroscopes, and wheels, and it is also essential for designing machines and structures that involve rotating components. Moving forward, now we will learn about angular velocity and acceleration. Angular velocity is a measure of how fast an object is rotating around a fixed axis, and it is usually expressed in radians per second. It is calculated by dividing the change in angle over time, and it is a vector quantity that has both magnitude and direction. Angular acceleration, on the other hand, is the rate at which an object's angular velocity changes over time. It is also a vector quantity, and it is calculated by dividing the change in angular velocity over time. Both angular velocity and acceleration play important roles in rotational dynamics, and they are used to describe the motion of rotating objects. Do you know about moment of inertia? The moment of inertia is a measure of an object's resistance to rotational motion. It depends on the mass distribution of the object and the axis around which it is rotating. The greater the moment of inertia, the more difficult it is to change the object's rotational motion. Moment of inertia is an important concept in rotational dynamics because it helps us understand the behavior of rotating objects under different conditions. For example, a figure skater can increase their moment of inertia by extending their arms and legs during a spin, which allows them to rotate more slowly and maintain their balance. Now, torque and angular momentum. Torque is a measure of the force that causes an object to rotate around a fixed axis. It is calculated by multiplying the force applied to the object by the distance from the axis of rotation. Torque plays a crucial role in rotational dynamics because it determines the rate at which an object's angular momentum changes over time. Angular momentum is a measure of an object's tendency to continue rotating around a fixed axis. It is calculated by multiplying the object's moment of inertia by its angular velocity. Conservation of angular momentum is an important principle in rotational dynamics, and it explains why objects tend to keep rotating unless acted upon by external forces. Hope you understood about torque. Let's learn about rotational kinetic energy. Rotational kinetic energy is the energy associated with an object's rotational motion. It depends on the object's moment of inertia and angular velocity, and it is calculated using the formula K equals half I omega 2, where K is the kinetic energy, I is the moment of inertia, and omega is the angular velocity. Rotational kinetic energy is an important concept in physics because it helps us understand the behavior of rotating objects in different situations. For example, it is used to calculate the energy required to start or stop a rotating machine, and it is also used to analyze the behavior of celestial bodies such as planets and stars. Moving on to our last topic, applications of rotational dynamics. Rotational dynamics has many practical applications in science and engineering. It is used to design and analyze machines and structures that involve rotating components, such as engines, turbines, and gears. It is also used in the design of spacecraft and satellites, where precise control of rotational motion is essential. In addition, rotational dynamics is important in many areas of physics, including astrophysics, where it is used to study the rotation of celestial bodies such as planets, stars, and galaxies. It is also used in material science, where it helps researchers understand the properties of materials that exhibit rotational symmetry, such as crystals and polymers. Here we have ended with our today's topic, rotational dynamics. Be sure to subscribe to our channel to stay updated with our latest videos. Have a good day.